So, good afternoon everybody. Welcome at the presentation of RF elements. So, first of all, a couple of basic facts regarding RF elements. So, we are based in Slovakia, close to the borders. We were established in 2010 as a brand, but actually we had many previous experiences with RF engineering before. Now there are more than 70 of us, and we mainly focus on innovation, so that's why our products don't just look differently, but they also work differently. So today I would like to talk about symmetrical horn and the technology that we improved, and we are the only vendor in the world who is producing this type of antennas. So actually, first of all, what the symmetrical sector is. Whoa. Goes one more up. Go back. Yeah, here we go again. So actually, as you can see, the main difference between traditional sector antennas and symmetrical horn antennas is the shape of the beam. So, as you can see, the shape of the beam with traditional antennas, it's flat in horizontal cut, but actually it's really narrow in a vertical polarization. On the other hand, what we did is that we made the same polarization, and actually it is physics, it is not us that we made a miracle, but it's just the physics, you know. So both polarizations are completely same. This is what I'm talking about. Here you can see the azimuth cut for horizontal and vertical polarizations. So both of the polarizations form the same beam pattern of these antennas. These antennas bring you many advantages comparing to the traditional sector antennas. So first, a huge advantage is that the coverage without null zone. With traditional sector antennas, you have the null zone of approximately 400 meters. Whilst on the other hand, with symmetrical horns, you have the null zone of only 20 meters. That means when you have even a close clients to your AP, you are able to connect them with the same access point, what is not possible with traditional sector antennas. The other huge advantage of the symmetrical horns is a frequency constant beam. So as you can see, with the change of the frequency, the main lobe of the antenna is still the same. Whilst, on the other hand, if you check how the beam changes in traditional sectors, you can see what's happening with your main lobe. When you are changing the frequency, the vertical polarization is getting more wide, but the horizontal polarization is getting more narrow. That's why you can have the problems when changing the frequency. You still have the same radio, the same antenna, but actually you have the problems to get the good signal quality and throughput. And that's because this is how traditional antennas behave. So, to see that I'm not telling you dreams, these are the real specs from our lab. So as you can see, the gain through the polarization is same in both of them at once. Okay, so now my favorite slides. Actually, I think many of you already are facing the biggest issues with the interference. And actually, the interference is caused because of the side lobes and the back lobes of the antennas. So actually, the green light is what you really need from the antenna, and that's why you are buying this antenna. So, okay, I have the customers here, then I'm happy. But actually, when you collocate, let's say, 4 APs in one tower, this is what makes your huge problems. Because the back lobes and the side lobes are affecting the other APs around. But on the other hand, if you check like the shape of the beam of symmetrical horns, the signal is dedicated only to the angle where it is supposed to go. So you are not spreading any side lobes and any back lobes to the other APs. This is the simulation of another antenna which has already pre-installed shielding in the back, but actually not each piece of metal can be called a shielding. You know, for a shielding, it's really important to know how to do that. And actually, as you can check, yeah, it eliminated the back lobe of the antenna. It's not so critical right now, but actually look what happened with the main beam. As you can see, all this main beam is moved to the left side, and for a MIMO technology, that's a huge problem. Now, this is something just for you to see. The other quite famous CPE. Look what happens everywhere around. This is just like all bad. Should never happen. Now, actually, the most common solution right now, if you have the problems with your antenna, first thing that most of the WISPs do is that, okay, I will increase TX power. TX power on the radio, TX power on the antenna, just burn everything around. All bad. This is why the spectrum is already killed, why everybody else is having problems with installing the other APs. This is something that you can increase TX power, like we did it in here as well. But if you can check, you're still spreading the signal only to the area where you really need it. So what's the solution actually is that you can increase TX power to the maximum on the antennas which are really made for that, but you will get the same result here with 10 dBi antenna as you will get with 20 dBi. You will still connect clients in 10 kilometers, but actually you will miss these side lobes and back lobes. So your signal is really dedicated only to the place where you need it. Regarding symmetrical horns, we are producing them by 10 degrees steps. So starting with 30 degrees, then 40, 50, 60, 70, 80 and 90 degrees. So now it enables you to make easy collocation and scalability of your clients when planning your network, or on the other hand, when you need to split your network. This can be a good solution for you, and you will only get the best possible signal quality and all this stuff. So the other thing is that these antennas are really compact. They are just 25% of traditional sector antennas. So that means that will bring or save your cost on the tower when you are paying for that. And we are not using any materials that are like poor in the quality, let's say. We are all the time using just robust and durable material like aluminium, which is extruded or whatever. Also, the random is made of polypropylene, and we are also using stainless steel for the brackets and UV-resistant ABS plastic for a twist port connector. So this is just the examples, because there are many questions, you know, like regarding what distance can I get of this antenna. So first of all, the distance depends on the environment. Second of all, it also depends on your client. So, you know, the distance cannot be said like, okay, you will achieve 20 kilometers all the time. So as you can see, these are the real results from our customer in South America. One of them reached with 30 degree symmetrical horn 25 kilometers. As a CPE, there was 31 dBi UPnT used. And the other guy with 60 degree symmetrical horn reach 23 kilometers link with 30 dBi client. Now, actually, like here in Austria, your terrain is more or less with the hills. So actually that's why symmetrical horns are really good to be used in here, because traditional sectors, as it was presented in the third slide, they have flat shape of the beam. So you are able to connect, let's say, only this area with traditional sector. But what about the other clients, you know? So due to the shape of the beam and same horizontal and vertical polarization on symmetrical horn, you are able to connect all these clients with just one AP. It also matters on the down tilt that you will make on the antenna, but like now, you are covering all your clients with one AP only. So, actually, these symmetrical horns, I don't want to tell you that they are best for everyday usage everywhere. It really depends on the situation, on your environment. So, the best possibilities of installing symmetrical horns and getting the most significant improvement is when you are facing a high level of interference. As I mentioned, they don't have any side lobes. That means that you are not even spreading the interference, but on the other hand, you are not receiving this interference from the other APs. Also, they are very good to be used when you need to use a narrow sector, because, you know, so far you were pushed like, okay, traditional vendors were providing you like 120 degree, 90 degree, 60 degree and 45 degrees antenna. You were done. But what to do when you have clients in 100 degrees? Why to use 120 degree antenna? First of all, you are spreading the interference, you are receiving this interference in these 20 degrees, and on the other hand, you are losing your money, because you are spreading your signal to the places where nobody is located. So for you, that means no money. Simple as it is, you know. The other very good situation is to split overcrowded sectors. I will show you later on one use case from US, which is about that, you know, because sometimes you have too many clients connected only to one AP. Of course, you cannot get higher throughput, of course, you cannot get higher speeds, and everybody said about that in nice words said. So actually, now you have the opportunity to split the sectors to more smaller, and it will bring you additional new clients to these APs, not only existing clients. The other, as I mentioned before, are hills, mountains and valleys, where you are able to connect clients with just one AP. The other thing regards to the null zone that I show you, it has the null zone or dead zone of only 20 meters, so that means you can connect your close clients. The other thing is when you have a space limitation on your towers, there's no place to expand, you cannot build additional tower, they are really small and compact, so you can use them there. And also when you have wind load issues, you know, because like traditional antennas are really huge, you know, and we are selling them across the world, like in the areas with a lot of typhoons, you know, and that's a really huge problem because they cannot do that, you know, with so big APs. So this is just a marketing slide, just to have like imagination of the angles, of the gain and everything. Just here I would like to emphasize, you have to stop thinking of the gain as it is the only thing that matters in the antenna. Your gain, first of all, is lost while when you are connecting the radio to the AP. Because you are using pigtails, and now even the best pigtails in the market, they have a loss. So of 20 dBi antenna, you will never get 20 dBi. Forget it. It's impossible. It's a physics. So here we made a twist port connector, which I will show you later on what is actually a waveguide feeder. So there are no losses on any RF cables and anything. So this is what I'm talking about, the waveguide feeder and our proprietary patented system. So we are the only one who's having that, and I believe it will stay like that for a future. So let's see what is the difference. What I was telling you, in a current setup, you have to have the antenna, you have to have a pigtail, and you have to have a radio. But actually we don't think it's a good, and that's why we decided to remove all the parts that are not needed there. First of all, pigtails out. These are losses. Connectors out as well on both sides. Radio and also the antenna side. Then the connectors, and what we did the next, we took a waveguide feeder from the antenna side and we placed it to the radio side. This is what you can see inside the twist port adapter. This is the yellow thing inside. And now, actually, you will just slide it there through the waveguide feeder, you will connect it to the antenna. So, eliminated losses on the pigtails, on any connectors. That's it. So simple. So actually how it works. Who saw the twist port adapters on the ball already know that it's really revolutionary simple. You don't need to have even a high school for that. You will just click it and you are done in 3 seconds. And as I said, it's virtually lossless. We say virtually because absolute zero does not exist in the world, you know, but actually when you compare it to a traditional setup with the pigtails and connectors, you will not even see any loss. So, as I mentioned, we are providing this solution for most of the radio vendors, or most popular radio vendors in the market right now. So as you can see, there are UBNT devices, there is a Microtech and Cambium as well. So they just made connectorized radio compatible with our twist port antennas. How does it work? You will just slide the radio inside. When you need to release it, you will just push the button. Nothing else. So here you can see just a brief list of twist port adapters for UBNT devices. So it's compatible with 5 AC light, 5 AC point-to-point or point-to-multipoint, Rocket M5, Rocket 5 AC Prism, and just yesterday there was launched new twist port adapter for A-Fiber 5X at the Vispapalooza. Also for EPMP 1000. For Microtech router boards, so everything starting with 9.1, 9.2, 7.1, 4.1, and we are providing this solution in shielded, non-shielded version. And actually, what I want to emphasize, all the twist port adapters are wideband. That means they operate from 5.1 to 6.4 gigahertz. Just up to you what frequency you need to use. You will already get it in one package. So this is how it works. This brief installation of Microtech router board inside the router board. Twist port adapter, sorry. So you will just fetch it there, connect it, and you are done. Now, what we have launched as well as the vendors are providing many unconnectorized radios, especially for project solutions. We have also introduced sector symmetrical horn antennas like carrier class with N-type connectors, and they are also produced by 10 degrees, starting with 30 degrees, then 40, 50, 60, 70, 80 and 90. So again, really easy collocation of your client. So this is the customer use case that I told you before. This guy had the original setup of 4 UBNT antennas, but actually he had a problem because these sectors were already overcrowded and he didn't have any space for like new APs to bring new clients on board. So that's why he went for 30-degree symmetrical horns with shielded twist port adapters. So it is how it was before. So he had the problems with low performance due to the number of clients, 185 clients and 4 APs, didn't have any space, and he was sharing the space with another 2 service providers. So this is the solution. Just one pole with 3 symmetrical horns, so he added 34 customers per 1 AP, so he got more than 100 clients with the same conditions. He does not face any interference issue, even though these symmetrical horns, they are overlapping, but because of they don't have any side lobes, they are not interfering each other. And we are not talking about the time that he saved on the labor and installation at all. So here you can see the comparison. As you can see, the quality, then there is a signal strength. Everything is just much better. This is another guy from US. He also had like some issues with the frequency, so that's why he decided to go with horns and Rocket 5 AC with port adapters. This is the guy from Nigeria. I have never believed that in Nigeria they have so huge problems with interference, but I was so surprised when I got this feedback. And actually this guy, he was not able to do 2 megs per client with a signal strength of -67 dBm. Then he started to use 640 degrees symmetrical horns, and actually now he's even able to operate at 80 megahertz channel. The other guy is from Albania. It's like they made the installation for Albanian Telecom. So if they are installing it for such institutions, I think there should be no doubt that we are not selling a dream, but a real AP, you know. The other guy, this is from Alaska. I mentioned it to some guys, you know. Actually, this is an older photo. He added a couple of more horns over there, but this was the original which we got. So as you can see, they are not interfering each other, even though they are overlapping. This version was even unshielded, but there is no problem at all. It's still working, and he's upgrading all the time. So yeah, we have like many of feedbacks in our YouTube channel. We also have our own community, which is called rfelab.com. So there you can find many like useful advantages and many skills of our end users. And we are also in all social media, so just follow up and you will get all the news from us. So actually, thanks very much for your attention, and I hope that I introduced something new to you, and you will think of that. Cheers!